Let's now take a look at some exam questions regarding permutations and combinations. The first one is from a May-June 2005 paper, the paper 6, and it's question 7 over here. Let me just check if this is correct. Yes. It says, a football team consists of 3 players who can play in a defense position, 3 players who can play in a midfield position, and 5 players who can play in a forward position. 3 players are chosen to collect a gold medal for the team. Find in how many ways this can be done if the captain, who is a midfield player, must be included together with 1 defense and 1 forward player. Again, if one of the people is already picked, you can exclude it and take it out of the equation, out of the number of people that you are dealing with. Particularly, you must exclude a midfield position, right? So what are you going to be left with? You are going to be left with 2 players, 1 defense and 1 forward. Again, the order doesn't matter, okay? The 3 of them, you have to calculate the number of arrangements for 2 of them. So that's 1 out of 3. Again, if you have 1, it doesn't matter if you use combination of permutation. I defaulted to combinations. And 1 out of 5 for the forward. Okay, multiply, that's 15 different arrangements. How many ways can this be done if exactly 1 forward player must be included together with any other 2? So you are now dealing with 1 out of 5 for the forward. Again, doesn't matter if it is combination of permutation. But now for the rest, the order doesn't matter and you have 2 of them. Okay, so if the order doesn't matter, what matters is the use of combination instead of permutation. For this one, it doesn't because you only have 1. But here you have more than 1, so it matters which one you use, and you have to use the combination. And how many you have? You have 6 of them. Okay, so this gives a total of 75 different arrangements. On B, you have find how many different arrangements there are for the 9 letters in the words gold medal. Okay, if there are no restrictions on the order of the letters. So again, this is a letter question. You have a total of 9 letters. You have 2 repetitions of 2 letters, the L and the D's. So applying the rules, this is just 9 factorial over 2 factorial times 2 factorial, each one corresponding to the L's or the D's. And this is the result. Now, the last one, if the 2 letters D come first and the 2 letters L come last. Okay. If you take the D's and the L's, you do not have to, and you count them as a letter, you do not have to count them anymore. There are no internal arrangements within the D's and the L's because they are the same letter, all right? And their positions are fixed and you are left with the 5 letters to be arranged with no repetitions now because the D's and the L's are already out, the ones that were repeated. So you basically have 5 factorial, that's 120 arrangements left. Next question is from a spring 2015 paper, paper 61, and it's question 7 over here. Find how many different numbers can be made by arranging all 9 digits of the number 223,677,888 if there are no restrictions first. This is similar to word problem. Instead of letters, you have numbers, okay? If you look at it, you have 9 digits. You have 2 repetitions of the digits, that's the 2s and the 7s, and you have 3 repetitions of 1 digit, that's the 8. So you must apply the rules that you've learned for words here. You have a total of 9 digits, and then that's what you have on top of the fraction, and then in the denominator you put the repetitions. So 2 factorial for the 2s, 2 factorial for the 7s, and 3 factorial for the 8s. And this is the result. Now, arrangements. Now, if the number made is an even number, for it to be an even number, it must end in 2s, in 6s, or in 8s. How many possibilities do you have? Well, what is the likelihood of occurrence of this? You have 6 different shots out of 9, which corresponds to 2/3. Let's count. 1, 2, 3, 4, 5, 6. So 6 possibilities out of 9. This means that you have 2/3 times the overall number of possibilities, okay, which is 10,080. Then you have Sandra wishes to buy some applications, some apps for her smartphone, but she only has enough money for 5 apps in total. There are 3 train apps, 6 social network apps, and 14 games apps available. Sandra wants to have at least one of each type of app. Find a number of different possible selections for 5 apps that Sandra can choose. So, what are the options here? If she wants 5 apps and at least one of each, I put all the possibilities here. So you have 3 for train, 6 for social network, and 14 options for game. So one possibility is that she gets 1 train, 1 social network, and 3 game, or 1 train, 2 social network, and 2 game. And well, you have here all the different possibilities. For each one of them, you have your own set of combinations. Again, the order doesn't matter for the number of apps that are bigger than 1, okay? So for this one, for example, you have 3C1 times 6C1 times 14C3. Here you have 3C1 times 6C2 times 14C2, and so forth, okay? So you calculate the number of possible arrangements for each of these arrangements, and then you add them together to find the total number of arrangements. Last exam question is from a June 2009 paper 6, and this is question 4. And it says a choir consists of 13 sopranos, 12 altos, 6 tenors, and 7 basses. A group consisting of 10 sopranos, 9 altos, 4 tenors, and 4 basses is to be chosen from the choir. In how many different ways can the group be chosen? Okay, so this is what you start with. This is what you want. Okay, you start with an overall of 38 musicians. The order in each group doesn't matter, so you are going to use combinations. For the sopranos, you have 10 out of 13. For the altos, 9 out of 12. For the tenors, 4 out of 6. And for the basses, 4 out of 7. Multiply them together, and this huge number is the total number of possible combinations. In how many ways can the 10 chosen sopranos be arranged in a line if the 6 tallest stand next to each other? Now you're focusing only on the sopranos, these over here. And you have 6 of them, which are the tallest, and they need to stand next to each other. If you pay attention, this is the same kind of question as a word question, in which you have 10 letters, and you want 6 of them to be grouped. What have you learned? You learned that you consider this as a single letter and you count it using the same rules that you've learned before. And then you have to consider the number of arrangements within the group, all right? But now that you know about permutations, you can go a little bit more technical and realize that the real reason why things are done the way they were taught in the beginning is because of permutations, right? You have a group of 6 tallest with its own arrangements within this group of 6 of the tallest sopranos. And then you are left with what? You are left with this group, which count as a single person, plus the 4 remaining sopranos, right? So this is going to be 6p6. Here the order matters, all right? And 5p5. Or in other words, that's 6 factorial times 5 factorial. That's what you learn over here. All right. Where was it? Yeah, over here. Okay. If this is the rule that you've learned before you actually learned about permutations. Now, the last question is, the four tenors and four basses in the group stand in a single line with all the tenors next to each other and all the basses next to each other. How many possible arrangements are there if three of the tenors refuse to stand next to any of the basses? All right, so you have four tenors and four basses, and you have three of the tenors which are rogue tenors, and they, for some reason, don't want to be next to any of the basses. So this leaves one tenor to be the one in between them, right? So you have basically two groups with one individual, which is a tenor, standing in the way of these two groups. Make sense? Again, this can be thought of as a word question in which you have 8 total words, in which you want one group of 4 to be together, and one group of 3 to be together, and one letter, sorry, to be standing in the way of these two groups. Okay, so you have, you can think in terms of the tenors and the basses, that you have the group of 3 rogue tenors in the left, the tenor that is in between the groups, and then the four basses on the right, or the 4 basses on the right, the tenor in between the groups, and the 3 rogue tenors, the 3 rogue tenors in the left, right? I think that's all this right. Yeah, I have it written anyway. So basically what you have 3, the order matters for the tenors. These are the rogue tenors. 3p3 for the rogue tenors times 4p4 for the basses. Okay, this leaves a total of 144 combinations. In this case, you have the tenors in the left and the basses on the right. And you have the exact same number for the situation in which you have the tenors in the right and the basses in the left. The tenor that is in between the groups doesn't count. All right, he's standing there, so there is no more arrangements for this person. Okay, so you have a total of 288 total arrangements.